Hello, everyone. Welcome to course P23, Common Contact Tip Failure Modes. I'm Bob Bosworth, your host for the next little while, going through the very common factors involved in contact tip failures and starting to deal with some of the solutions to each one. Basically, understanding what's wrong and how it happened leads us to the solution. So let's go through some of the most common of the three conditions that we see most likely in a cell and why a contact tip ended up dying prematurely. The first one being a burn back or a melt over. I try to refrain from using the term burn back, but it's so common because burn back is actually a feature inside of some of the welding programs that make sure the wire is short enough that it doesn't make contact as it moves from weld to weld. So keep that in mind. But the burn back I'm showing here is basically the wire has stalled in some form for whatever reason. Very commonly, drive roll slippage as a result of unmaintained conduits, and it stalled it long enough that the extension has shortened and welded it right over cleanly at the end. The next one is stubbing condition. This is probably the most common, where you actually go in to try to fix it, and quite often you'll try to turn it out and the wire will kind of pop and do a little bit of a snap, so it's temporarily fused itself. We'll explain that a little bit. And the last one is understanding the spatter buildup. If you end up with a lot of spatter in your tips, or if it ends up trying to freeze the wire or encroach on the orifice exit, it turns into a bigger problem. So we'll have a look at that for a few minutes as well. So a quick word on contact tips, contact tubes as they're called sometimes. We have to understand that the wire has to rub on the inside. Now, I'm not a fan of wire straighteners, and I'm not a fan of them because I'm doing everything I can to try to keep the wire as in the condition that it left the drum as I possibly can, or the reel, or the reel, or the spool, or anything like that. So it doesn't matter what you do to straighten it out. It could become a problem if you straighten it out. Remember, we need to rub on the inside of the contact tip. We need to rub on the inside of that orifice to make sure we got good connection. If that wire, wherever that's straight, that it could kind of bounce around inside there, I said you're going to get bad electrical contact and you're going to have bigger issues as a result of that. So take caution with wire straighteners, I guess is the point here. Using tighter tolerance contact tips, especially for longevity and accuracy, is usually recommended during robotic applications. Tight tolerance represent about 5 thou clearance. Regular tolerance represent between 8 and 11 thou clearance. So the first one, contact tip, or what's commonly referred to as a burn back, mostly happens in the late stages of the welding. Let me take a moment and explain that I'm always interested in where in the weld, when somebody says I got a contact tip dying, where inside this weld does this commonly happen? At the beginning, middle, or the end of the weld? So this tells me, and this is one of my key features, was the contact tip at its hottest during this particular cycle, or was it cold during this particular cycle? Whereby I would end up looking at the weld before and finding out if the condition of the wire was being presented to the next weld better. So when you see this condition, it's commonly happening in the late stages of the weld. And it's usually wire feed inconsistencies, or if you got a burn back timer, which is a parameter, as I discussed before, right? It's way too long. Remember, the extension has suffered for some reason, the extension being the area that the wire comes out and then where the voltage pinches it off. So if it becomes way too high, or the wire becomes short and the voltage doesn't change, it eventually works its way back to the chip and actually welds it right over. I'd go over, if I saw any of these coming in, I'd be going your wire feed speed inconsistency. Look at everything. And don't forget when you're checking your wire, one of the things I like to do is to cut the wire back at the drive rolls, behind the drive rolls, and take the drive rolls off, and I'll actually slide the wire back and forth while I'm cycling through. While I'm cycling through, and I'm just going through from point to point, right, in teach mode. And now I'm checking the consistency and the flow of the pressure on my resistance as I'm going at each one, making sure that the wire can slide back and forth while I'm checking each point. I've learned many times doing this exercise that that there's certain choke points where the whip or the conduit is giving us all kinds of problems because of the location. Just knowing this problem often figures out why this particular weld, is always a problem. So if you examine it that way, you can. So checking for any level of wire inconsistencies, drive rolls, bulks or binding, anything. And now, as soon as you've done all that, you've changed it, remember to check your parameters and get some cross sections done. Right? Things change, and sometimes people have made parameter changes to compensate for a problem. If you no longer have the problem, don't always immediately assume everything is going to be fine. Go back and get some validation done and make sure it's all done correctly. Number 2 is the contact tip, the stubbing. This is probably the most common, and this happens right at the beginning. Now, the problem with stubbing is that, and sometimes it's burned all the way back and the little piece is not sticking there, but it's just stuck on the inside, is the wire was making contact at the start of the weld. So if you look at these most commonly, and these are the ones you could kind of loosen off a little bit and it'll just pop out. And that's because the wire was held back when the current was applied. The wire couldn't move. And it might have been up against a silicon island. Don't forget the end of that wire is marginally, after it's been welded on, is marginally conductive. You're going to have a chunk of silicon island on the bottom of that wire that's going to push back, and silicate is glass, is an insulator. So when the stubbing condition happens and it pops out, this is commonly from that wire making contact with the surface. So it held it back long enough that the current flow basically popped that little piece off. Sometimes it shows up. Sometimes it's sitting there as a little fish hook where it left in the spot where it's stuck. Sometimes it's gone completely. But the key feature of stubbing is to go back and look and make sure that it actually made contact with the plate. There was an arc mark on the plate where it's supposed to start. Make sure the stubbing condition wasn't happening as a result of the finishing of the previous weld. That it wasn't, the extension was very short and it was dying at that stage. The earlier problems happening in one weld, the more likely I am to go back and make sure the finish of the previous weld was correct. The next weld will only be as good, start as well, as the last one finished. Always make sure the wire is not touching the weld area. I think I've been through that very clearly now. And you have to take extra care if you start getting involved with a crater fill in your previous weld. And don't forget what burn back does. That burn back feature that you're setting, after the wire stops, after the machine says stop welding, it applies just a tiny bit of current and stalls the robot from leaving, a tiny bit of current to shorten it. And when it shortens it, it's making sure that the wire is not touching the next weld. But take caution with that cute little feature to make sure we don't touch that next weld surface before the contactor pulls in. Because if you do it too much, if you run it too long, it's usually there's a timer involved, it'll make a larger ball. Remember, the larger the ball, the bigger the silicate island on the back end of that wire is going to be. Because silicate islands show up on the wire the same way those silicate islands, the little bits of glass, are all over our regular gas metal process. The last one is a spatter buildup. It's usually poor development. It usually has to do with poor development, but don't get too caught up in the idea this could be all parameter development. When the lesson a while back on heat input. Let's just talk about heat input for a second. If I've got a contact tip that's overheating, and it's made of copper, and we know that these particular class 2s are somewhere around 1800 degrees Fahrenheit before they get to the melting zone. If a contact tip is overheated, the spatter will stick to it and literally start to collect. Now, I'm deeply suspicious. Notice right in here, that there's a bit of spatter stuck right to the edge of the nozzle. Well, that is telltale for me, because the very edge of the orifice is going to be the first area to melt. It's the closest to the plasma, and it's a corner. corners always melt quicker than a nice large surface that requires more heat input to try to get it to melt. So when it's right on the corner like that, I have a couple of suspicions that the contact tip itself is overheated. And also be careful of lipping. There's actually a condition where weld metal will be all the way through that contact tip from the top to the bottom, and it'll come out like looking like a little tongue. It won't be a little spatter ball. It'll come out looking like a little tongue. So we have to develop some parameters to complement the stick out. We have to make sure that we're far enough away. Now, you could have accessibility problems that are putting you in this case as well. Well, thank you very much for your time. If you have any further questions about this, you could always contact me. Numbers right there. I'll give you a few moments to write it down. Let me know if you have any other issues or concerns, and we'll take it from there. Okay, thank you very much.